So far we've talked about two forms of lines. We've talked about slope-intercept form and point-slope form. Today we dive into the final form, standard form, okay? And for standard form, there's two things that need to be true. So we ultimately want our equation to look like this. AX plus BY equals C. So ultimately that's where we want to end up. And there's two things we have to do to make that happen. We need to multiply to get rid of any fractions, and then we're going to move X and Y to be on the same side of the equation. Okay, so that's kind of the two things. No fractions, X and Y have to be together. So let's take a look quickly at just how do we make that happen? Okay, so here, how do we get rid of that fraction? Well, I look at the bottom, so I look at the 5, then I'm going to multiply everything by 5. Everything in that whole equation, I'm going to multiply by 5. So that's going to give me 5y equals negative 2x plus 15. Okay, everything gets multiplied by 5, and notice what that does. It cancels off that fraction. So the first thing I already have done, okay, I have no more fractions. Now I just have to bring x and y together. So I'm going to add the 2x over now. I'm going to add 2x to both sides of my equation to have this. That is the standard form. Again, x and y together and having no fractions. The second one, this time my issue is I have a 4 on the bottom. So I'm going to multiply everything in this equation by 4. That's going to be 4y. It cancels off the fraction, then leaves me with negative 20. All right, and now the idea is, again, I need the x and y together. So I'm going to subtract off my 3x from both sides. So I'm going to have a negative 3x plus 4y equals negative 20. And again, that is going to be my standard form. No fractions, x and y are together. So let's talk about how we can apply the rules from previous videos into finding standard form equations. So basically, the same rules apply, okay? So the rule being, put it in the form that you know first. So usually 99% of the time, you're going to put in slope-intercept or point-slope first, and then transform it, okay? So let me show you what that looks like. So here I'm given a slope and a point. So remember, with the information given, that lets me write a point-slope equation, okay? Y minus the y value from the point equals the slope times x minus the x value from the point. So that's what we've got as of now, okay? So that is a legitimate point-slope equation, but it says it wants it in standard form. All right, so standard form means no fractions, and it means x and y are together. So let's talk about how we can make that happen. Okay, so here, if I go to distribute that 2/3, now here, negative 2/3 times negative 2. Well, negative 2 is the same thing as 2 over 1. So that would just give us that. Okay. So Right now, I have an issue, don't I? Okay, right now my issue is I have a bunch of fractions that I don't want. Okay, so if I want to get rid of that fraction, remember what I have to do. I'm going to multiply every single thing in this equation by 3. Because that is going to cancel both of those denominators away. Okay, so that's what I would do first, is I would get rid of the fractions, because now everything else is going to fall into place a little bit easier. Okay, so now I can add this 12 over, and now to get x and y together, I can add the 2x over. And get that as my standard form. So again, basically the same rule as yesterday. Write it using the given information, figure out which formula you can write it in, then transform it to the one that you need. Okay, and in this case, again, to transform it to what I needed, had to do away with all my fractions and get x and y together. Let's take a look at another one. Write the equation of the line in standard form that passes through the points 4, -1 and 2, -1. And I apologize, I just realized that my copy here is different than yours. So I'm going to change this to match your copy, and that is going to be a 2, okay? So let's look at the information that we're being given. We're being given these 2 points, okay? When I'm given 2 points, remember that means I'm going to be able to write a point slope form equation. And remember, the reason I can do that is because when I have 2 points, I can actually find the slopes between them, right? Subtract the y's and subtract the x's. So that's going to become a positive. 2 plus 1 is 3. -2 minus 4 is a -6. So we're going to have a slope of -1/2. Okay, and so what we're going to do is I'm going to use that slope, and I'm going to just pick that point right there, and let's write our point slope equation. Y minus y value from the point equals our slope, x minus the x value from the point that we chose. Right? And I flip that double negative to be a positive. And there is my point slope equation. Okay? So point slope isn't what it asked for though, right? What it asked for is standard form. So now that I have an equation written, now I have to get it into the correct format. Okay? The correct format means now I need no fractions and I need the x and y together. So to make this happen, I'm going to distribute the -1/2. So y minus 2 equals -1/2 x. -1/2 times 2 is going to give me a -1. All right. So now I see that I still have a fraction left in this mess, right? I see this 2 here. So I'm going to multiply absolutely everything by 2 to get rid of that denominator. So 2y minus 4 equals, now that's going to cancel, so I'll just have -x minus 2. I'll multiply everything by 2 in order to cancel out that denominator. All right? And Now I have to do the second step, and that is getting x and y together. So I'm going to add this 4 over. I'm going to combine my constants first. 2y equals negative x. Negative 2 plus 4 is a positive 2. Then add my x over. So x plus 2y equals 2. That would be this equation in standard form. So again, the rules from the other notes still apply. Use the information that you're given to determine what type of equation can I write, then manipulate it to be in the right form. So, as always, thank you for joining me for this, and make sure that now you can move on and start working on your practice work.